Thank you very much, Pietro, for that kind introduction. I look forward to giving you some thoughts on technology and change in disruptive times, and welcome everyone to this event. I started my architectural education at Fanshawe, actually, and then went on to pursue my degree. That architectural technology program really provided a great foundation for me in my career. I wanted to start by talking a little bit about disruptive technology. We live in an era of considerable change, there's no question, and change that's often the direct result of technological innovation. In the past few years, we've been hearing more and more about disruptive and technology and also disruptive innovation. But these terms were coined actually more than 20 years ago. And during that time, I think that architecture, engineering, and construction have not been immune to these forces that are, in fact, reshaping the built environment. The American scholar who first defined and analyzed these terms separated new technology actually into sustaining and disruptive. Sustaining technology relies on incremental improvements to an already established technology. On the other hand, disruptive technology lacks refinement, often has performance problems because it is new, appeals to a limited audience, and may not have a proven practical application. I think those of us that have been in the business for some time may have experienced some of those things. I know that I have, and Paul is agreeing with me. The incremental improvements, however, of sustaining technology can be considered evolutionary. I think of them as evolutionary, while disruptive technology is actually best described as revolutionary. These changes in digital technology have offered, and I think will continue to offer, benefits, challenges, and opportunities for all who have a role to play in designing and constructing the built environment. We hear so much today about the pace of technological change because it's in fact exponential. For some of the biggest technological innovations of our history, we can measure success at the level of users. Hitting the coveted $50 million user mark is a sure indicator, but how quickly those top technologies taking to reach that magic number is, I think, even more important, and this chart demonstrates that. If we compare some of the biggest consumer products from the last 250 years, we can easily identify a trend. And in today's tech-fueled and tech-led world, top products are reaching high levels of consumers in incredibly short amounts of time. If you take a look at some of the, what I call old school technology, it took 75 years for the telephone to reach the homes of 50 million people on a global level. By comparison, it took radio just 38 years to have 50 million users, and television just 13 years. These technologies truly revolutionized the way we communicate and view the world. Then came the World Wide Web in 1989. And in 4 short years, 50 million users were surfing the internet. It's incredible. Once again, the face of communication technology had been reinvented. In fact, I think this could really be considered the true beginning of today's interconnected world. From the internet, we got social media. Mark Zuckerberg released Facebook in 2004. Today, of course, we know Facebook is the world's largest social media network with over 2 billion users, and it took Facebook just 2 years to reach that 50 million mark. Despite its popularity today, this actually is quite slow compared to other social media channels. Instagram took 19 months, as you can see, YouTube and Twitter, 10 and 9 months respectively. And today, with the simple availability and popularity of mobile apps, reaching 50 million users seems to be getting faster and faster. Games such as Angry Birds and Candy Crush are doing this in less than 2 months. To date, interesting to note that the fastest downloaded app of all time is Pokemon Go in 19 days. 19 days to reach the hands of 50 million people. Of course, there was a platform for this. This ubiquitous platform was the iPhone App Store, and it's what allowed people to reach out and download that app. I think what's happening today as well is we're taking for granted that which is right before our collective noses. If you look at Uber technology, for example, and consider how quickly the app has altered the way so many people get around major areas. Of course, Uber couldn't have come into being without large numbers of people having a powerful location-aware mobile technology in their collective pockets, and I'm sure we all have that technology in our pockets with us this evening. The iPhone, which just celebrated its 10th anniversary, actually is about 12 years now, and Uber are so omnipresent today that they serve as props in films and almost pass without notice. It's easy to ignore not only the speed at which disruptions cause technology is affecting society, but the acceleration in the pace of change. This has an effect on markets, and I think lots of industries are being disrupted. We're seeing it in material science and architecture, chemistry and energy storage, big data and artificial intelligence, and I think there's no doubt that technology will continue to follow this trend. I tried not to populate my presentation with too many graphs and charts and a plethora of numbers, but I did use one here just to demonstrate the three laws that of technology. And I think the first and most widely cited law states that a processor doubles in speed, in capacity every 2 years, and that's been true since 1970. The second law states that at a fixed computing load, the amount of battery you'll need will fall by a factor of 2 every 18 months, and this has been the case since 1945, believe it or not. The third law states that the amount of data storable in a given space will double every 2 years. Conversely, the same amount of storage space will halve in price, and this has been true since 1990. For those of us that are engaged in creating the built environment, the vast advance of technology means a few things. I think if we look at property built today, we can expect that if that building lasts 50 years, it will face technology 30 million times more powerful than today. For those that inhabit those buildings, an 11-year-old will see a 64-fold increase in computing power by the time they finish high school, and an executive moving from graduation to management over 20 years will face technology 500,000 times more powerful than the day they started work. Crazy stats. Speaking of high school and careers, if you could indulge me for a moment as I really date myself here and reflect on the impact of technology that I've experienced over time. Anybody recognize this? Of course. Just the old guys, that's right. It's a slide rule. Grade 9 math for me, we had to learn how to use this instrument that could quickly do things like multiplication, division, squares and square roots, and other more complex math functions more quickly than you could do it on paper. At the same time, we had to purchase a leading edge of digital technology that could do even more complex equations even faster. The calculator. If you take a look, I don't know if you can see it or not, but along the side here, this baby could even compute. It tells you it could compute. Add, addition, subtraction, multiplication, division, even squares and square roots. Even had an owner's manual. And it was about the size of a large cell phone, today's cell phone, but about 3 times as thick. It even came with its own carrying case, so you really looked like a nerd carrying that thing around. It lasted me through high school, and during that time, there were probably some evolutionary improvements to the calculator, but nothing really revolutionary. As I started my education, however, the tools of the profession were still the mechanical pencil, some Pantone markers, and always the important eraser. I truly believe that, and I continue to believe today, that architecture is 60% erasing. So, yeah. Technical ink pens and the Leroy lettering set to get that precision lettering were there too. I didn't really have the opportunity to experience any technology of any sort in my early education at Fanshawe. until we had to do a specifications course. Where we had to use a Keypunch contraption that I typed in the specification sections that I needed for my project, and it spit out these key cards that I then submitted, and a week later, voila, I had my specification. Spit out from an IBM mainframe, I think, that could fill a room. So some of these laws of technology, I think, are evident here. When I started my career, however, it was still very much a manual drafting world. Both design and construction drawings were done manually, and it wasn't really until about 3 years later, the mid-'80s, that I first experienced disruptive technology. The principal of the firm that I was with came to me and said, our clients, like the university, Bell Real Estate, and the hospitals are telling us we need to start using CAD, or we won't be getting any more projects from them. That was an easy business decision for the boss, and he said to me, it's your job to learn CAD. So, onto my drafting board, landed an IBM Model 80 along with a copy of AutoCAD 2.18. That computer had a whopping 4 meg RAM, and this is the one that stuns me, 140 meg hard drive. Today, when we put drawings together, individual drawings can often get larger than 100 meg, or models certainly can. I also think that the watch I have on my wrist probably has more computing power than that thing did. Came with 100 commands. 100 commands. And I said architecture 60% erasing. It did have an erase command, but this version didn't have an undo. No undo and no redo. It did have an oops command, however, that allowed you to go back one command. Redraw and regen. You had to be careful with those. If you had a drawing of any size at all, you'd go and get a cup of coffee. Actually, if the drawing was really large, you could make a pot of coffee by the time it did a full regen. But with this technology, you could draw the space shuttle. Okay, it's a 2D line representation of a space shuttle, but if you were really good, you could draw a 3D model. It's still a 2D representation of that space shuttle, just done in ortho mode. However, in the architectural profession, when you learn the software, you could produce good drawings quickly and efficiently, and more efficiently than hand drawing, especially for repetitive elements that were quickly reproduced with copy and block commands. The business thinking of the day, however, was that one person, because they were more efficient, could do more drawings in less time, so fewer employees would be needed, but that certainly wasn't my experience. Drawings were still taking the same amount of time. The reason for that is that more options could be explored with the ease of changing a drawing. And remember I said 60% of architecture is erasing or deleting or undoing and redoing and undoing and undoing and redoing again. So I think the theory behind this is that the opportunity was further exploration of the design and hopefully a more satisfied client, and if it was a well put together package of drawings, a better building as a result. Renderings, the 2D AutoCAD went through evolutionary changes that allowed you to generate 3D drawings, and with rendering software such as Autodesk's 3D Studio or AccuRender, which was used to produce this rendering about 20 years ago, you could communicate in 3D to a client what the space would look like. Now, when you had finished applying materials and lighting, you'd hit the render command and then have a snooze. That's not me up there. On larger, more complex renderings, you'd hit the render command at the end of the day and come in the next morning praying that the computer didn't crash overnight. Let me fast forward to my time at Western. I'm moving into this century now, so bear with me. Before I go into some information about my experience with digital technology at Western, Some facts about Western. We are a research-intensive, residence-based university. 35,000 students, full-time equivalent in our constituent university. Almost 5,000 staff. From a facility standpoint, we have over 9,000 square feet in more than 100 buildings on campus, including our research parks, our residences, and our apartments. From that standpoint, we really are a city in microcosm. And with that in mind, we're experiencing digital technology, its challenges, opportunities, and benefits. And the best way for me to share that with you is to look on some projects that we've completed within the last 10 years. I say 10 years because from my perspective, it really aligns with what I've seen as wider adaptation of BIM in the architectural, engineering, and construction community. Delaware Hall is a student residence. It was the women's residence built in the 60s. It is a full residence now, young men and women. In fact, this year at Western, it was the first opportunity that we have ever had to allow co-ed dorm rooms, interestingly enough. We completed a full renovation of this project in 2016, the interior renovation that included all new mechanical, electrical systems, new windows, and actually it achieved LEED Silver certification. What I was seeing at that time is consultants were using BIM, but it was really architects only. I think the mechanical, electrical, and structural engineers were dabbling in it at best. And that challenge isn't new to the industry. I saw it with CAD implementation as well. The MEP software was always lagging behind the architectural software. So the engineers were playing catch up with the digital technology. Just a few facts unrelated to CAD and BIM as far as digital technology goes. When we go through the LEED certification process, measurement and verification is really important. In order to do that measurement and verification, we install meters. LEED buildings, we're seeing about 65 meters, including sub-meters, being installed in our buildings. We currently have over 500 meters in all of our buildings, and this allows us to more carefully measure utility use on campus. And then there are the building controls to monitor the indoor environment. Actually, in Delaware, as a student residence, we have controls attached to every window. Students are prone to leaving windows open, going home for the weekend, or going away for a week on reading week. We will know what buildings are open, and we can arrange to have them closed. Really important in the winter because we've had situations where windows are left open and fan coils freeze up, and then we have a mess on our hands throughout the building. Controls have really evolved as well. Originally, pneumatic thermostatic controls have migrated to digital technology. I think a disruptive technology innovation that was truly revolutionary. The pneumatic controls were a mechanical device, obviously digital controls, electronic. Today, we have close to 90,000 control points, I/O points in all of our buildings that we now monitor remotely, and also have the ability to monitor from portable devices. Thames Hall is a project that we're currently in design with, and what I'm seeing on this project, and have for the last few years, that BIM is being utilized throughout the design process and will be carried through the production of contract documents from all disciplines. This interior rendering really demonstrates, I think, the opportunity for more fulsome design exploration and development of the BIM model earlier into the design process. Challenge there is that more time and effort is put into the BIM model earlier in the design process. And in theory, it results in less time, somewhat less time for the production of construction drawings. What we're seeing, however, is that the overall schedule is still about the same. It does have some impact on fee allocation, consultant fee allocation, where there's a need or a desire on the part of the architects and engineers to charge more fee up front because they're doing more of the building model earlier in the process. The challenge for owners is that this has not been reflected in our fee structures, due in large part to the fact that the professional associations have not captured these changes that we're seeing in the industry in their standards agreements for professional services. The Amit Chakma Engineering Building was just completed this summer, was occupied for full use in September. This is a rendering that was produced during the design process for this 100,000 square foot facility, which is targeting LEED Platinum. Early in the design process, exploration and BIM really clearly communicates the design intent, and that can carry forward into the design development phase to produce room data sheets, to capture room-specific information to share with our stakeholders to make sure we have everything right. And then that information can be utilized to develop the model further for contract documents. I show this photograph of the building that was taken just after it opened. And I think what's interesting here is it really exemplifies how closely the original model communicated the end product. Some digital technology features, actually this band of windows that you see here utilizes electrochromatic glass or smart glass. It's electronically tintable glass that's used in the windows that can be directly controlled by building occupants, and it's great for improving occupant comfort, maximizing access to daylight and outdoor views, and important for us as well, reducing energy costs. The other thing that you can just see on the roof of this building is an array of solar panels that give us the opportunity to produce electricity that we can utilize within the building. I wanted to talk a little bit as well, I alluded to it in the last slide, about smart buildings or building analytics and the Internet of Things. Building analytics really provides insightful data that can be used to optimize our facilities' energy performance and remove any inefficiencies. I'll tell you why that's important for Western, and the best way for me to convey that actually is tell you what we pay on an annual basis for utilities. Electricity is by far and away the highest, and 2 years ago we paid in excess of $20 million for our electrical bill. It was actually reduced last year by about $5 million through the provincial government's fair electrical pricing program. Water is $2.4 million a year, and gas is about $5.1 million a year. So we're challenged with those objectives of energy efficiency, not only energy efficiency, but security of our buildings and reliability. Moving to automated systems and platforms along with building analytics solutions ensures that we're staying abreast with the trends in the marketplace. And building analytics is really the single most powerful tool that we can use to make informed decisions about meeting our energy goals. Also related to the energy and sustainability is universities in general in Ontario and their move to low carbon university campuses. We're really trying to help the province reduce greenhouse gas emissions and save energy by rethinking campus operations. They're leading to research on clean technology, electric cars, alternative fuels, and next generation batteries. For us in facilities, by renovating and retrofitting old buildings, we're reducing energy use and lowering carbon emissions. I think, how does that relate to us and the audience in front of me here tonight? I think it means opportunities for those AEC firms who truly are agile, stay abreast of upcoming trends, disruptions and threats, mitigate the risk that technological change poses to employees, and position themselves to become experts in the design and construction of buildings that move us along the road to low carbon university campuses. Now some thoughts of mine through my research on technologies that are changing construction. The first one I would mention is one you may not think of, and that's drones. We actually utilized a drone recently to assist in a bridge inspection that would have been really difficult to access without erecting scaffolding or renting a really expensive and hard to come by bridge master. The result of using that drone was better documentation, of the bridge bearings than we've ever had previously. It can also be used to map out construction sites digitally, providing footage of difficult to access spaces and really providing a higher level of accuracy. 3D printing is another thing that we're starting to experience, and the price of those 3D printers is coming down. Actually, in Copenhagen, it's a Copenhagen-based company, completed the first 3D printed building recently. They used a gantry-type printer, if you can imagine that, 8 meters by 8 meters by 6 meters. And they created the structural walls of what they call the building on demand. One of the partners in that company said, as well as the obvious benefit of reducing construction costs, the use of 3D printing makes it possible to embed wireless sensors into the walls and achieve full integration of technology in the built environment. Smart devices are being used more and more. I just read recently that Ellis Dawn is starting to utilize tablets on their construction sites. And we know that checking a project over and over can take a large amount of time, but newly developed apps and mobile-based solutions are not only quicker to input information into, but it means a paperless system that ensures no information is lost. Architects are now using virtual reality and are really benefiting, I think, from the visualization of their designs, and it's creating opportunities for some forms of business transformation that supports stakeholder engagement and collaboration. I did want to talk about building information a little bit. Interesting to note that the United Kingdom's government, aside from Brexit, implemented a BIM initiative that was mandated in 2016. And what's happening there is it really is speeding up the modernization of the sector and shaping the future of the industry. I think that building information modeling, BIM, is a revolutionary technology. For me, it was like going from the drafting board to CAD. BIM is like going from CAD to building information modeling. What's interesting is that unlike CAD, I'm seeing early adoption by contractors. That wasn't the case with CAD. Contractors didn't feel there was a business value add. But certainly the benefits are tangible today. Build it once virtually and then build it on site rather than building it on site twice, increasing time and cost. Today, there is the potential for BIM construction data to be used to support what we as building owners feel is important on the operations side to automate maintenance schedules during the building life. At Western, we're certainly not there yet, but we will require BIM models to create virtual copies of facilities and infrastructure by integrating the models with sensors that I've talked about, the Internet of Things, GIS, our FM applications, and other IT systems. As I said, we're not there yet with lifecycle BIM, and there are a few things that we'll need to understand to make it work for us. We'll need to understand more about a common data environment and why it is really critical for us. We'll need to know how to continue to use 2D materials such as PDFs and DWG files while upgrading to new BIM workflows. We'll also need to know how to migrate from a project information model to an asset information model. As well, we'll need to understand how to integrate critical data and models connected to our facilities management software, which is Archibus. There are opportunities for mobile BIM to make immediate decisions in the field. And then, as I've talked about, BIM and the Internet of Things for optimal building performance. So much of what we read about the pace of change is, especially technological change, is designed to make us fearful. But I really think that a little bit of fear can be helpful. It generates the pressure to act and a willingness to deal with the new. And this is necessary for any transformation. For those who maintain some semblance of optimism, remain agile, and can adapt, the opportunities and benefits for architects, engineers, and contracts, I think, will really outweigh the challenges along the way. As I wrap up my presentation, this lithograph by Dutch graphic artist entitled Hands Drawing Hands, I think is a great metaphor for the collaborative team-based approach that design and construction should be for those of us who create the built environment. With the pace of technological change, we may not know what digital communication tool will be in our hands or who or what the other hand will be. For the students in the audience and for those starting their careers, I would say that learning doesn't stop with your formal education. It's a lifelong process. It certainly has been for me, and I've really benefited by opportunities that digital technology and those disruptive technologies, revolutionary technologies have offered me. So I would encourage you to remain curious, embrace change, and if you do that, you will grow both professionally and personally. Thank you very much.